Just wanted to highlight a couple of two courses that are coming up quick here. There is an exam coming up. There's an exam preparation course. And there's also one of the master's series, the second one, I believe, Controlling Water and Vapor. This is through Graham French and RDH. Also with Pathways to Passive House Certification, February 1st is the next Certified Designer course. And then starting in February 3rd would be the next Certified Passive House Tradesperson. So those two courses are coming up. Obviously, these days, both are online. I also wanted to mention we have launched now. There's what we're calling self-paced courses with Passive House Canada. So this is part of that new e-commerce system. These are courses that you can go on and they're all pre-recorded videos that you can take at your leisure. These, I highlighted two of them. Up and running with Design PH. So that's a in-depth course on the Design 2.0 Design PH 2.0 plugin. And then also the thermal bridging calculation course. Both are really good courses, and I think they provide good value, and you can do it whenever you want. So you don't have to meet these 2 o'clock, 2:30 random times live. So you can do it at your leisure, and they do count towards some pretty good CPD points. I was going to launch a quick poll now. So I'm going to launch a poll, 2 questions. Please answer them just so we get an idea of what's there. Question 1 is who is in the audience. Question 2 is where you think your passive house knowledge is at. We've got predominantly a good number of architects and designers. A couple of engineers, some builders, no one from the government, 1 homeowner, and a few others. Maybe in the Kumospaces, the others let us know what I missed in that category. Knowledge-wise, we've got a few beginners, early days. A lot of us, I would put myself as an intermediate knowledge base, are in there. And then we've got 1 person claiming an expert. You can figure out and try and guess who that person is. All right, so on to today. Big fancy, and I apologize for the blurry logo, David. Stark Architecture. Starting January, I've noticed more and more projects from Stark, and I just felt we needed to sit down and talk a little bit with David, if you will. I've known David for a few years now. A mutual friend, an architect, Jason King, introduced me to David about 4 or 5 years ago, basically because we both would only talk to him about Passive House. And so we figured we needed to connect. Stark's got a number of exciting projects. They have been working predominantly, I'd say, outside of Vancouver, which I think has been a big part of his success, in all honesty, avoiding all those deep rules that Ara was talking about. And so that's where I want to start it. So I'm going to stop my share. And I think, David, how do you want to do? Do you want to jump right into your presentation?
Yeah, sure. I mean, I've got a bit of an intro and I can just go through it from there, and then happy to stay and answer any and all questions afterwards.
Okay, let's do that. You should be able to share. Let me know if you can't. Perfect.
Yeah. Let's see if I can make it full screen. Okay. Everyone good? And let me know if it starts lagging, but it should be okay. Yeah, so hi, I'm David from Stark Architecture. Stark was founded in 2012, based in Squamish now. We did have an office in Vancouver for a while, but we moved up here selfishly because I moved up here to live. We're a 6-person firm. I think it's important for me to put the team up here as, you know, every project that we do is a collaborative effort, not just with Stark, but all the other sort of groups and contractors and sub-trades. I wanted to talk to you today about 2 projects that we've completed that are Passive House. One is certified, one didn't end up getting certified. The first one is Tantrum. It's a bike shop collab office space in downtown Revelstoke. This actually became the first commercial office building certified in North America. unique to that kind of commercial and office use. So yeah, it's a 3,000 square foot site, 6,500 square foot building, 3-story. There is a actual full basement underneath here as well. And then a mezzanine sort of 3rd floor that you can't see from the street that's sort of stepped back. Just a tiny little bit of context, just because it was kind of fun. We went to the museum there and we managed to pull some photos of the original site. So these 2 gentlemen walking in front, that was the original house that was built before the 1900s. It then burnt down in 1979 and then was a sort of gap site ever since. The 2 buildings either side still exist. So we had to be very conscious of fitting the building into that sort of streetscape. The image to the top right is the First World War Armistice Day parade with the kids going past. So it kind of shows you the history. And then the contractor and I joke that the 2 guys on the left are me and the contractor when we started the design process with the city, because it takes a long time with them. So that was back in the 70s. So then just jumping into a bit of the process. Oops, go back up. So yeah, as I explained, it's a pretty thin site. Really constrained either side. Our elevations on the west and east are the long elevations. They're sheltered and bordered by buildings on most parts of it. We wanted to obviously work with the client to get as much sort of usable space as possible, but the client actually came to us in tandem with the contractor, who's tree construction from Revelstoke, that they really wanted to push this as passive. Stark had actually designed the client's house a couple of years before this, so they were keen to keep pushing the high performance. And what you can see there is the kind of volumes massing on the site, pushed back to allow for parking. Then the ground floor in the 4th image pushed in again to create sort of shading entry spaces and sort of a streetscape elevation. And then the upper floor pushed in again so that we could allow light to get into the deep plan. And then the last move was on the elevation, being conscious that we had a smaller building to the right-hand side facing it. We actually angled the wall back so that it kind of, you know, speak more to the smaller building, but also has the added benefit when you walk along the street, particularly from downtown, which is to the right, you can actually see the facade of the building. To just quickly go over the floor plans, basement, you know, full basement storage area, which we then integrated into the passive house for to get our kind of envelope area volume calculations up. And then the main floor is the bike shop, commercial space for the client. Is a husband and wife. She has the offices upstairs and he has the bike shop. It's Tantrum bike shop in Revelstoke. Highly recommend it if you ever go. Then the second floor is sort of like semi-open plan offices for a collab that they were going to install there. And then the upper floor was this kind of unique kind of mezzanine area at the back, which then allowed for this double height space below, which served a couple of different purposes, which, as I mentioned, was to get the light into the plan, which was a deep sort of plan. So we needed to get lighting in there. And then the second thing that actually kicked us into was we were able to then keep this as a Part 9 building, as opposed to adding another floor, which then would have caused greater escape routes and things like that. And we really just didn't have the buildable space for it. And then it also reduced our fire requirements slightly. And then, yeah, so this exploded axonometric kind of dives into, there was a lot of different components that sort of built up this building, and they all had passive in mind, but they also had a foot in kind of constructability, timeline, budget, just as every build typically does. The walls on the sort of like the west and east elevations, the sort of demising, the sort of zero lot line walls, they were a prefab concrete panel, a sandwich panel. You know, 4 inches concrete either side with a 5.5 inch insulation between them. They were chosen largely because of their fire resistance properties and also because we could actually install them very quickly. They were installed in a matter of days by a crane. They then were bridged by intermediate lignature floors. It's a timber cassette system from Europe where they're able to actually pack the timber cassettes with wood fiber, or they can drill into the underside for sound attenuation. They were again sort of prefabricated, very quick to be installed. The shear walls were all created using CLT. And then the sort of very south and north walls were the only walls that were stick framed, 2x6 with 280 millimeters of wood fiber to the exterior. Just a couple of quick sections of, so this is kind of explaining on the left-hand side, the concrete sandwich panel, concrete inside out, and then the polyiso on the interior. This was the thickest concrete panel that they'd ever done. So it took a little bit of pushing to get them to kind of engineer one this big. They typically do your kind of Walmarts and your Canadian Tire, so they're not big on, you know, putting as much insulation in as they can. And then the one on the right is a kind of section through the cantilevered floor. So you're looking at the lignature cassette, then wrapped all the way around two edges with the wood fiber. Just some more details here. We really, you know, this was a stage where not only did we have to do our psi calcs and work out other things like that, but it was just the blending of each one of these different systems. In an ideal world, we would have built this all out of CLT, but we ran the numbers, we spoke to people, and at that stage, and maybe even still today, the requirements would have been CLT exterior wall on a zero lot line with rock salt to the outside, hardy board, some sort of non-flammable construction. And then on the interior, we were quoted as needing 5 layers of drywall. So, you know, in an ideal world, we would have had simpler detailing between systems, but this is kind of how we got away with it here. I just wanted to jump in. I know the audience, so there's lots of passive house designers and people that you know these sorts of drawings, but I just kind of wanted to share some of our drawings just to kind of show you how we work out TFA calcs, and you can kind of see with a commercial building how kind of complex they get, especially with different angled walls, different height ceilings as well, and how they correspond to how they are calculated in the overall TFA, you know, and what sort of ratio they are kind of given to. Another interesting, well, I think interesting drawing for us is that we didn't really have consistent R values through the walls. So your PHPP, when you're modeling, you know, your envelope, well, when you start to go through full certification, the actual walls and floors aren't as simple as you might think. The slab required significant slab bands because it was the slab, the basement slab that tied the walls together. So we had to do separate calculations for each R value based on the constituent proportions of, you know, concrete to insulation. So again, it's kind of, I don't see people sharing PHPP drawings too much. So I always think it's kind of interesting that we should try and share these because it can help a lot of other people, you know, work through these problems. Similar with the exterior walls, these concrete walls, they have concrete ribs within them. So when you look at a perfect section and it shows 5.5 inches of insulation, you're not actually getting that all of the time through these. So again, there's 4 different depths of R insulation, which then form different parts of R values to these exterior walls. So these are the sorts of drawings that we put in for the certification process. But we were also very conscious of when we were doing our initial modeling, not to believe too much in the kind of general overall R values of our envelope. These are volume drawings as well, just to kind of show you different heights and the influence that they have on the calculations. And then, yeah, just showing the verification at the end. So yeah, we ended up hitting the 0.4 for the pressurization test. Heating demand was very, very close, and similarly with the heated load. This was not an easy building to certify based on the lack of solar gain, essentially, and the limited amount of windows. We could only put windows on the south and north elevations, and as you all know, putting windows on the north elevation isn't very sort of, you know, is frowned upon a little bit, but we needed natural light. And then we had to push-pull. We didn't want to over-insulate the walls. But we worked with Tad from Certifiers, and he was very helpful, but it got very, very tricky. We were down to working out, at one point, the primary energy demand was so high, we had to kind of redo all these calculations. We had to work out how how often the modem would be in standby versus being active, because that kilowatt draw usage was actually affecting our numbers. So it got a little bit, I'm going to say a little bit crazy, but this was a kind of first for a lot of people. Some construction shots just showing you those concrete panels being lifted into place and braced. You can kind of see the exterior fins are thinner. You can kind of see the insulation on the interior face, and then interior insulation in the center, and then the concrete on the interior. We then installed a steel plate where all the floors hung onto. Top right is some of the lignature panels being lifted into place, braced between the two concrete units. There's our beautiful Zender ERVs in the basement. We used ERVs because of the climate up there. You know, we want to save some of the energy in the air as well. And then bottom right is the exterior, the front and back, the front walls framed, and then the wood fiber installed and the windows put in. And what was funny was there was a newspaper article in the local paper saying that the building was finished, and they didn't really like the color of the cladding. They thought that this was the finished product with no strapping or cladding. So here's the finished product, which I think looks a lot better. It kind of, you know, speaks to that single story street frontage for the shops. The upper story is that sort of larger unit. It kind of looks similar to the building on the left. The mezzanine is pushed really far back when you're on the street close to it. It looks like a two-story building. Inside, the interior designer, Well Interiors, they worked a lot with recycled products, and the carpet that you see up there is actually recycled fishing nets from waste products. They're a great product. And then the tree construction guys, this is their office in this main space. They actually built a CLT little meeting room on wheels. And the bottom middle image, you can see that's looking up to see the lignature, the underside of those lignature floors I was talking about, the cassette timbers. And you can actually have them CNC in a shape pattern. And that really helps with the sound attenuation, because obviously with the concrete and wood, there would be prone to echoes, but that dissipates a lot of it. And then the street in the bottom right with the kind of metal siding on the top, but the brick on the lower floor. Yeah, the next project, ski cabin in Revelstoke again, same contractor, tree construction. This was designed at the base of the ski hill. It's a 3,800 square foot cabin. The client really came to us with a full appreciation of everything sustainable, green, energy efficient. She had previously been living in a kind of biodome eco home down in Utah, and then this was going to be her home up in Canada. So yeah, we really just pushed all of the materials and pushed all of the sort of the learnings from our other sort of high performance projects and integrated it here. Ran all the modeling and managed to sort of get, you know, really, really great results. And then, you know, the client chose not to go for full certification, but we, you know, there's a huge amount of techniques in here that I can talk about and share. So this is the long sort of narrow site into a sort of steep cliff over on the west. This is north-south here. So the building was orientated to actually take a primary view of Mount Begbie. To the south, rotated ever so slightly, which was great for our PHPV modeling. The floors, you know, there's a full basement underneath there. The main floor then has a mezzanine master suite above it, and then there's this garage, large garage for sort of toys and things, which is outside of the passive envelope. And there's this triangular pergola that links everything together. She is one of three sisters, so we designed the building as, we call it Trinity, arranged around a triangle. It has a triangular roof. There's a triangular motif that runs through it. And then, yeah, we decided to go with full CLT construction for this one. A couple of reasons: short building season, excellent carbon embodying, and then, yeah, just beautiful interior finish as well. The image to the top, you can start to see these. I'll explain them a little bit further, but there's the Curto kind of knee braces on the exterior. And then the image below is the sort of, finished CLT there with the windows going in, built out on boxes. This then had 280 millimeters of wood fiber on the exterior. So again, I kind of wanted to just jump in and see some details. Like, they're by no means perfect, but this is kind of where we got to. Insetting our CLT walls back from the ICF, being very conscious that we needed to maintain a kind of smooth line between the exterior cladding and the ICF. There was 6 inches of EPS put onto the outside of these ICFs. Lots of consideration for the intermediary floors, which were CLT, but then had a framed floor above to run all the HRVs in, because we were leaving the CLT exposed. There was some really unique glazing details built in, utilizing the performance of the CLT panels to put in kind of sort of wall section in the middle here, this angled window. Some more sort of shots of the windows going in, and then this is the master bedroom in the bottom left. Really, again, if you're going to use CLT, don't cover it up, and use all the CNC and you can to create these cool shapes that then no one needs to do much to it afterwards. And then on the right hand side, it's a kind of funny photo because we sent this to the client, and I think it was kind of early spring, but she thought it was sand. And this is actually them cutting down chunks of wood fiber. So you can kind of see the guy with a saw in the bottom right. These are 280 millimeter chunks that they're then put up on a flush, flat CLT wall. Makes for a really great, really simple building envelope, and just super insulative and super airtight. I just wanted to kind of jump into this because it's something that this is the first time we'd come across this system, and something that I've never seen since, but we worked with Woodall Engineering. Funny story is we actually went through 2 other engineers before Woodall, because everyone wanted to put a glulam or a steel frame inside of this CLT. And, through our pushing and the contractor pushing, having seen buildings like this pop up all over Germany and Austria and Switzerland with no steel inside them, that this could be done. So these are these, I don't know if you've come across them, but they're these Curto LVL angle braces that are screwed through into the CLT, and then they act as a kind of pincer. And they're, there's a lot of them, but they kind of crimp the walls from the outside, leaves the interior fully free of any structure. And then what was great is because the insulation was thicker than them. The timber itself, they had a pretty good R value, so there wasn't a ton of thermal bridging. So we were able to get a pretty great system there. So we were happy with that. Just sharing another couple of exterior, the windows. We had a big opportunity, obviously, to put full height glazing on the south, but we were conscious to have a 2-foot overhang there to stop sort of the overheating. On the east wall, which faces the garage, there wasn't much opportunity for windows anyway, which was fine. North wall, 0 windows here. West wall, a little bit of a problem. We needed a lot of windows there, but all but 3 windows are overhung by a 2-meter canopy or balcony. So that's some of the sort of techniques that we use if we are going to have to put windows in, to kind of make sure that they're shaded. And then, these are some of the interior shots or finished shots. The client's a sort of intrepid traveler, and they were able to, put really nice pieces in here and work with the interior designer. Beautiful Rayco window system and no structure inside, which was great. Little bit of a funny story with the fireplace, being that it's an incredibly expensive fireplace, and we were adamant that you couldn't actually light it because the building was so airtight that the contractor ended up having to put in a make-up air system just to provide enough air into the house for the fire. So it's that fun battle between, the realities of passive, but also the realities of just client wants and needs. And when there's 10 meters of snow outside and you just want to light a fire because it's human nature, I guess. Yeah, those are the two projects. I mean, there's the Tantrum was started in 2017, and the ski cabin was started in 2018, and Tantrum finished a year and a half ago, and the ski cabin finished a year ago. So there's a huge amount of information and lessons, and you know, I definitely didn't put myself as an expert in that poll because we learned so much, and with the projects we have on the books right now, we're still learning. So I'm really into sort of sharing our experiences and sort of discussing if there's any questions you want to ask. Nothing's off the books. I can answer pretty much everything. So yeah, and then just wanted to shout out the teams. Huge part of both of these projects, the contractors as well as the interior designers, TAD at certifiers, and then the structural engineers that we were lucky to work with on both these projects. Yeah. Thanks.
That was good. Appreciate it. Those are two amazing projects that I selfishly, being able to pick the projects we get to talk about, really wanted to see. A trip to Revelstoke a little while in the fall. I got to see Tantrum and went inside, and it's an impressive building. So
yeah, thanks.
Jump right into questions. Roger, why don't you just directly ask your question? If you want to unmute, you can just ask David that question you got.
Sure, thank you. I had a question about your modeling, but it looks like you had the Passive House certifiers do your modeling.
No, so four of our staff here are certified Passive House designers. We begin all of the modeling in-house.
Oh, great.
Yeah, because we had to go for full certification there. There wasn't necessarily a handoff. We definitely worked hand in hand to get the information, and he was invaluable in just finding all the many loopholes and quirks in the software, especially pertaining to commercial building.
Yes.
You know, I never thought I'd be trying to find a spec sheet for a modem and work out how many hours a day it was in standby mode, and you know, and how many laptop screen. You know, it was crazy. But as you can see from the values, we just scraped by. Houses are a lot easier, obviously. So yeah.
Got a couple more questions. That monster heat exchanger in the basement of the building, was that the easiest solution? And the with the tandem house, how much stratification is there, do you think, when you actually measure it? Thank you.
Do you mean in the ERV and the bottom of the? Yeah. So that was it. Yeah, those were just two ERVs. One services the bike shop, and one services the offices. We were required to put an ERV or an HRV in there, and that was just the best solution for keeping the sort of moisture within the air. It was a bit dry there.
One.
Does that answer?
Did you do any post in the HRB? Are you doing any cooling or are you doing any conditioning to the air post?
No, there's no conditioning to the air, but to be totally upfront, we were always close with the solar game for this building here, and as it transpired, the modeling for the climate was obviously a little bit too optimistic that there was no cloud in Revelstoke ever. And so what we found was that in the fall, there were more cloudy days than sunny days. And so they then had to actually retrofit a couple of just baseboards just to provide some background heat on those sorts of days, but no cooling as of yet.
Roger's other question was to do with on the ski cabin, just the stratification, which is within that. With such high ceilings, how much stratification is there?
Oh, not something that I've ever calculated, I'm afraid.
Do you know if it's been measured?
No, when you talk about stratification, are you talking about like the air rising and?
The temperature difference between your floor and your peak.
Yeah, it was never meant. It was never measured. The very height of the ceiling over the living room, obviously non-accessible. But then at the back where the mezzanine was, there were bedrooms and sort of enclosed spaces. So they were, they weren't relying on air rising to heat them as such. But no, that'd be an interesting thing to work out.
Wayne, if you're there, why don't you ask your questions?
Hey, thanks. Yeah, basically looking at structural, what obstacles are faced by implementing CLTs is my first question.
What are the obstacles?
Was there any obstacles, any resistance? We know in commercial, obviously it's been adopted more and more due to structural strength and a green product, but it doesn't necessarily have the thermal performance. So what exercise did you go through to balance a green product with thermal performance, I guess is what it comes down to.
Yeah, well, fully related to the structural, there was massive problems with the structural. We did have to let two engineers go, structural engineers go, because they couldn't wrap their head around it. CLT was just too new, and it was classed as a kind of panel that you laid on top of a substructure, not a self-supporting structure that by its very nature wouldn't require any thermally bridged structural elements. So this is why we adopted this kind of Curto system, and that was the goal, was to have a structure-free interior using a environmentally friendly timber material, which it did, in our calculations, it did have a good R value. I don't know if that was, maybe you were asking that, but the R value of the CLT was a contributing factor to that overall wall assembly.
Well, I guess it's a combination of both. We got R1 per inch for wood, and then it's sort of balancing both aspects, right? Of a good structural product with high thermal value.
Yeah, which I feel that this is the best of both worlds for that, rather than going to say a SIP system, which is foam interior, that sort of thing. There's not many products like CLT that tick as many boxes for us for the sort of for that. Yeah.
So on a related note, these are some very cool projects, obviously. How's the cost effectiveness versus some other solutions? Where do you find how did it fit cost effective wise?
With the bike shop, a lot of the decisions were based on cost. So that was a big driver, the concrete panels, the speed of construction. If we were to look at block work, especially in Revelstoke with the labor, CMU blocks, masonry, you would be talking, vastly more expensive and vastly more time consuming. So there was a big bunch of drivers there. With the ski house, cost wasn't such an issue. So we were grateful to be a little bit more, liberal with our kind of, this is the best way to do it because it also looks the nicest. But ingrained in that as well is that, the CLT was fairly expensive. The wood fiber at that thickness is fairly expensive, but the piecing together of that system and not having, just taping CLT, for instance, and cutting large blocks of wood fiber, you then gain time. It's a simpler system, less callbacks, less mistakes. So, as we all know, there's no perfect system, but this made a lot of other jobs easier with a bit more upfront cost, if that makes sense.
Yeah, totally. What's the net price increase, decrease you feel in the end, including labor, whatever else? Again, I'm just looking at another bunch of projects right now, and it's like, how do we sell the value, right?
Yeah, and that's a tricky one doing apples for apples, because so many items in traditional building we just take for granted. That's the way it is, you know. The poly goes up and the electrician cuts all the poly. Well, someone's going to tape that, but I just factor that into my general price, right? I've never, to this day, come across a contractor who actually extracts how much it costs to retape all of like these mistakes. But with a high performance building, when your envelope is literally CLT and wood fiber, you remove a load of unknown mistakes that you may or may not realize that you make. So I can't give you an answer is the short answer, but I can just tell you that the simplicity of the system helped iron out a lot of problems.
Oh, that's great. Thank you. I'm just trying to figure out how to sell, because we're a wood-based province. There's so many good things we can do. I just want to find how to sell it.
Yeah, no, and we have the same problems as well. Honestly, yeah, we would love to design every house in CLT. We love the system. You know, just getting the stuff sometimes can be the end of the project because everyone's so busy with it. But through my career as passive, I've started focusing less on trying to save people energy and money, because they really, at the end of the day, they don't care too much about that. I start focusing on the indoor air quality and the fact that, you know, these guys can saw this to bits wearing shorts and t-shirts, maybe not in front of WorkSafe BC, but they're not wearing, you know, hazmat suits and masks and gassing. And, you know, if that happens to translate into a $5 a square foot uptick in price, it's sometimes that can be a lot more meaningful to people if they know they're gonna, you know, inhabit that building for a long time. So yeah.
I'd imagine too, within this system with the ski cabin, is even just that utilizing the CLT as your interior finish, interior finishing costs would be dramatically less than the drywall paint setup. On that note, how did you do exterior plugs? And I noticed some lights on the CL2. How was it with the mechanical systems and integrating that into the CLT?
Yeah, so that was and to your first point, you know, that would be a great way to just do some rough numbers is, you know, take all your square foot area of drywall and paint and just subtract that straight away and see if you're close. That'd be a good one. Cost saving. Yeah, the floor system, HRVs and electrical. So this was a panelized system designed in collaboration with Thomas Stitch from Stitch Consulting. And they take our architectural model and they actually router in all of the cavities for electrical conduit that run through the CLT wall panels. So the electricians can just pull wire. So that's really slick. HRVs were all run within interior framed walls, or we had that system where, I don't know if I had the detail, we actually built here. I don't know if you can see my little hand, but bottom left hand corner, this CLT floor, there is a 2x4 timber, like a framed floor on top of that. That's where we run all of the plumbing, all of the HRV ducts, all of the electrical that needs to get into other rooms.
Makes sense. I know that within this presentation, something that popped into mind for me is, and as a builder, seeing a lot of these new products, it makes me excited, but I'm also cautious of the lead times. So I know that the floor panel system that you used in the bike shop was really intriguing. Even just the detailing that they showed within those holes just makes it really unique. How are you finding even the corner braces lead time wise? Are those causing issues? Or are you getting it shipped from Europe relatively quickly, and just experience on there, I guess?
Yep. Well, this was in 2018, so shipping wasn't such an issue with these products, but we did run a pretty lean schedule. We were constantly worried that the panels wouldn't arrive in time. We have a very short window in Revelstoke. The concrete went up really fast, and then the site would have sat for 2 weeks, and luckily the lignature arrived. But there was contingencies there where we had sort of other areas where we pre-ordered everything as soon as possible, especially the windows. all the wood fiber, so they could arrive and sit in lots if we weren't ready for it at that stage. Yeah, the lignature system was just fantastic. Like, it was engineered and prefabbed and built in Europe, and they had the tolerances, which is kind of funny for European manufacturers. Tolerances are like 2 or 3 mil, and we were really worried because we thought, well, can we not just leave a 2-inch gap and we'll shim everything out? And to some German CAD guy is like sweating because that would be just terrible. He's like, there'll be a gap, and we're like, yeah, but we don't know how straight these concrete walls are going to be. but it all fit perfectly, and yeah, great to see that system and have a deck to work on straight away.
Yeah, I actually had the chance to work on both of these projects here in Revelstoke, and I can really speak to how well the lignature went together. It was really cool to see.
Nice.
Yeah. Oh, did you work for Tree?
Yeah, I did for 2018, I guess. Yeah. So I kind of showed up. I showed up kind of halfway through flying the lignature, and yeah, like I said, it was really cool to see. I think the engineers didn't quite trust it, so we had to do some extra like diaphragm nailing.
Yeah. But
yeah, it's a cool project for sure.
Yeah. No, that's the same with the ski cabin and this. It was a lot of, with any project of this, you have a visionary or someone who's just hell-bent on getting it done. It was like, the owner of Tree in this case, and everyone needs coerced or pushed or encouraged to do that. And engineers typically were the toughest lot to try and think outside the box and not do shear walls everywhere, not require massive, screws and huge nailing patterns. It's a rectangular box, but yeah, it is tough, but you just have to tell them they have to do it. And they find a way.
That's probably good. I guess that's one of them, but I'll ask Wayne's question, which was just on closing before we shift, is what are the biggest lessons learned on these two projects if you take it back? It was one of each.
Well, the commercial one was just being prepared for how involved certifying a passive house building is. It is not simple when it's a commercial building. And then, some of the design considerations that you have to change because of that. You're dealing with a commercial space where you have doors and the client wants the doors open and big doors, but they have to be passive house certified. That sort of thing for if you're going to do a commercial one. And then the second project, I would just say thoroughly research. If you're going to commit to going passive, as we were with the second house, thoroughly research your consultants. And we all have consultants we work with, and we really like, their teams, but they have to either have some experience or have the, tenacity to want to do a passive house project, because you can't get 3 months into structural or mechanical design and then discover that they actually don't really believe in the system, or they don't think that this is going to work. You get a lot of problems. So, yeah.
Sound advice.
Yeah.
I think we all, in the Paso's process, I think we all go through that one.
Yeah.
If you want to, I can force your stop share, but all right. Well, I thank you, David. That was awesome. I was, like I said earlier, I really wanted to explore those projects further, and that was definitely a good intro to both of them. I don't talk to you again, David. Thank you. That was really good, and I appreciate it. Looking forward to more passive houses. If David's all right with it, I can share his slide deck. I know that's often a question. I'll double check with him. I know that he's in the spirit of sharing, so not to put pressure on them in front of everybody, but
Absolutely. And then Chris, just one other thing is that with the drawings that we actually created for the certification for the commercial building, we actually have an educational set, which just has a watermark across it, but I can upload that to you and you can share that with whomever you want.
okay.
I just really want to tell people how to do certification drawings.
That I think everybody would appreciate that, and it's a good resource. So
Yeah,
I will do that. So I am going to because of the camera usage, I think we got to sign out of Zoom and head over to Kumospaces. So hopefully this works.
Okay.
Experiment.
Thank you, everyone.
Thank you.
Bye bye.